All right, let's go through this problem. A ball of mass 0.5 kilograms moves at 2 meters per second. I like to label it right on the picture. Toward another ball of mass 0.6 kilograms, which is initially at rest. The two balls hit and stick together. This is going to be an inelastic collision where we're going to add their two masses together and say that they're both traveling at that same speed. Find the speed of the balls after the collision. All right, collision indicates that this is a momentum problem and that I need to use the conservation of momentum during a collision in order to solve for the final speed. So whenever I do a conservation of momentum problem, I always start by drawing a before and an after picture so that I can just get a visual to set up my math. So I have ball 1 moving to the right and ball 2 at rest. And then afterwards, ball 1 and ball 2 stick together and move together at some new speed, v final. When I'm doing this, I'm going to say that the total momentum of both objects added together before they collide is equal to the total momentum of both objects added together after they collide. To solve for momentum, I'm going to use mass times velocity. So this would be m1 v1 plus m2 v2. But because the two objects are moving together as one here, I'm going to add their masses together and say that this total big object moving at this new speed is all one object with one momentum. And so now I can plug some numbers in and say that my 0.5 kilogram mass moving at 2 meters per second plus my 0.6 kilogram mass not moving have to equal my 0.5 plus my 0.6 moving at this new speed v prime. So 0.5 times 2 is 1, and 0.5 plus 0.6 is 1.1. And so my final velocity will be 1 divided by 1.1, which I will put into a calculator and get an answer in a decimal form of 0.91 meters per second. Okay, so that's my answer for part A. Now, the two balls get knocked off the edge of the table. So they're going to travel together off the edge of the table. And I need to know how far from the edge of the table will they land. So really, I've got both of these balls stuck together, 1 and 2, moving at this new speed of 0.91 meters per second. And I'm trying to find out how far from the edge of the table they're going to land. So I'm solving for D here, this range value. And so I'm going to just kind of look at this picture and kind of notice that this is a projectile motion problem. And that for my projectile motion problem, I always start by making an XY chart. And so in my XY chart for projectile motion, I know that my acceleration in the x direction is 0. My acceleration in the y direction, we'll just call -10. When I'm looking at these velocities, that 0.91 meters per second, that's all in the x direction. None of that velocity is in the y direction. This isn't just a projectile problem. This is a launched horizontal projectile problem. And so when they're launched horizontal, I can say that my starting y velocity is 0, and my starting x velocity is 0.91 meters per second. Now, in order for me to find how far from the edge of the table they're going to land, I need to solve for my time in the y, to find my time in the x, and my final calculation, delta x, is equal to the bulldozer here, but the acceleration in the x direction is 0, so we know that range can be found with x velocity and time. But in order to find time, I need one more piece of information. Looks like they've labeled h for me here, When I go back up, it tells me that h is 1.5. So this is a 1.5 meter tall table. And so when the height is 1.5 meters, that helps me find my delta y. My delta y, though, is going to be negative 1.5 meters because we're falling downwards 1.5 meters. To solve for the time, I'm going to use my y information. And so to find time, I'm going to say that my y bulldozer is going to be used. And my y starting velocity is 0 right here. And so what I'm really going to get here is negative 1.5 equals 1/2 of negative 10 t squared. So I'll divide both sides by negative 5. And now I get that t is equal to the square root of 1.5 over 5. So get out the calculator, do 1.5 divided by 5 is 0.3, and now I need to take the square root of 0.3, which is 0.55. So this is equal to 0.55 seconds. Okay, now that I know my time in the y is 0.55 seconds, that means my time in the x is 0.55 seconds. And so now I can use that. My delta x is equal to my x velocity of 0.91 times my time of 0.55. And so I multiply my 0.55 times 0.91, and I get about 0.5 again. Delta x equals 0.498 or 0.5 meters.